Myself Supriya Anand, Assistant Professor, Department of Electronics and Communication Engineering, RIT. We shall see the experiments on Analog and Digital System Design Laboratory, BECL305. In this video, we are going to see the BJT common emitter voltage amplifier with and without feedback. In general, a common emitter amplifier is a basic transistor amplifier configuration where the emitter terminal is common to both the input as well as the output. So it provides the high voltage gain with a 180-degree phase shift between the input as well as the output. If it is without feedback, the advantages are the high voltage gain, the low bandwidth, poor stability, and the linearization. Whenever we are going to provide the emitter with the feedback, so that will be the unbypassed emitter resistor introduces a negative feedback and which will be reducing the gain but improves the linearity, bandwidth as well as the input impedance stability. In order to make the design, we need to calculate or we need to find the RE, that is the resistance across the emitter, resistance across the collector, and the resistance R1 and R2. We need to calculate this by making the current, that is IB is equal to IC divided by HFE. So we are designing it over 0.04 milliamps. So then we can take the values for the resistance R1 and R2 as 3.3 kilohertz and R2 as 8.2 kilohertz. We have taken the transistor, that is SL100. You can observe here the output, we are taking it from the collector, and across the emitter we are having a feedback capacitance. If we are having a resistance, this is nothing but the feedback. You can observe RL, that is the we have taken it as 10 kilo ohms. We are going to provide the same for the base again as the feedback. So the procedure for this is to, at the initial, you need to give the sinusoidal wave as an input waveform. We need to set up a sinusoidal wave, and before that give the power supply of 12 to 10 volts and record the voltage what you are going to get across the oscilloscope. Find the values of the sine wave at the input and then set the sine wave amplitude of 20 millivolts, that is more sufficient. So we will get a mid-band frequency. Here you can observe the model graph, you can observe here. So these graph, the first graph what we are having, this is the output or the sinusoidal wave. Once we need to just vary the, once you set the input for 20 millivolts, so then you need to take down the readings accordingly. Reading should be by varying the amplitude. So by varying the frequency, by varying the frequency, you just go on increasing the frequency from 100 hertz to up to 3 megahertz. Take the readings from 100 hertz, 200 hertz, 300 hertz, then raise it to 100 kilohertz and megahertz. So take the readings value up to 3 megahertz and plot the graph. Once the graph is plotted for both with and without feedback, you will get a graph like this, which will be then further used to calculate the bandwidth. So here you need to calculate both the bandwidth for with feedback and without feedback of the BJT. Though the corresponding bandwidth values will be calculated, and we are going to calculate the output impedance as well as the input impedance. We'll see the circuit connections as well as the graph across the oscilloscope.
The circuit connection for the BJT amplifier with feedback has been connected here. First we need to set the input. In order to set the input, set the millivolts. Adjust the amplitude up to 1. Adjust the amplitude into 1. You can observe this is 1 unit. So the frequency is 1 unit now. This is done with the input. Then you need to check the output and calculate and take the readings for the varying frequency. To take the output readings, connect the ground from the input as well as the output. take the input from the base capacitor, output from the collector. Here I am varying the voltage into 1, so that will be easy for calculation, and I have set the time division for 1 volts. Anything multiplied with this value will be equal to 1 and easy for calculation. So once the setup is done, vary the frequency from 100 Hz and take the readings. Take the readings from 100 Hz up to 3 MHz. Here I have taken it approximately 100 Hz and calculate the divisions here. The sine wave is around, if you want you can change the amplitude, this is of 0.2. So 0.2 into 1 multiply with the time division and take down the readings. Next similarly vary the frequency into 200 Hz. Now you can observe this is of 1 volt, that is 1 unit. So 1 unit into the time division 1, take down and calculate the frequency. Similarly go on varying the frequencies up to 3 MHz. Take the maximum readings. At some certain point the frequency will become constant. At some certain point the frequency will become constant, and by taking the readings plot the graph and take down the calculation for the BJT amplifier without feedback.